Alright, it's time for another homework support video for Shapes and Designs 1.5. We're looking at pages 28 through 31 and looking at problems 13 through 16, 31, 32, 34, and 35. So hopefully you have your protractors ready and you are ready to start constructing some angles and thinking about some angle relationships. In problems 13 through 16, I'm asked to write an equation and find the measure of the angle labeled x, but without measuring. So as I'm looking at these, I need to be thinking about the angle relationships that I've been learning about. There are complementary angles, which add up to 90 degrees. So I might be looking for two angles that look like they are making a right angle in size. And then there are supplementary angles, which add up to 180 degrees. Again, you might think about how supplementary and straight angle start with the same letter. So again, those two angles are going to make a straight angle, or 180 degrees, versus complementary will make 90 degrees. So looking at 13, I can see I have angles here that make a straight line. So these are supplementary. So I'm going to go ahead and write a little equation here. X plus 30 degrees equals 180 degrees. And if I just think about that equation, I'm going to think about something plus 30 makes 180. And I can think about how 150 plus 30 would make 180. If I get stuck, I could always just do 180 and subtract 30 to find my 150 as well. On 14, I can see that I also have two angles that make a straight line. And so again, I can think about a simple equation here would be x plus 125 equals 180. So I'm looking for that missing piece to add to 125 to make 180. And again, if I get stuck, I can just do 180 minus 25. And I will then have, 5 here and 5 here, 55 degrees. And so again, this angle is going to be 55 degrees. 55 plus 125 would make 180 degrees. Looking down below, I can see in 15 it looks like I have a right angle here. So I'm going to write the equation x plus 27 equals 90. Again, I want to find that missing piece. So I might do subtraction. 90 minus 27, okay, would give me 63 degrees. And so in this case, angle x is 63 degrees. And finally on 16, I can see that these two angles combined are making a full rotation. So they're making 360 degrees total. So in other words, x plus 35 is going to make 360. So I can take 360 and subtract 35, again to find that missing piece. And at that point, I will have 325 degrees. So this entire angle out here, it's a really big angle, is 325 degrees. Again, because x, or 325 plus 35, would make 360. In problem 31, I'm being asked to estimate the measure of each angle and then check my answers with an angle ruler or protractor. And so we're going to start here with A by estimating. And again, remember, it's kind of helpful to draw in often some lines here to be able to think about benchmark angles. So for example, here I might draw in 90 degrees just so I can see that. I'm going to set this as 0 degrees. And I might think about, well, I can see maybe halfway would be about here. This would be around 45. So maybe my estimate is that this is around 50 degrees, for example, 55 degrees, something like that. So I'm going to make my estimate, and then I'm going to go ahead and grab my protractor, and I'm going to use a little protractor here as well. And so you'll see this protractor showing up, and I'm going to go ahead and sketch kind of in where I see this angle going, because I know it's a little bit hard to see. But basically this angle is going through 50 degrees. So again, as long as my estimate was maybe in the 40 to 60 range, something like that, then that's a good estimate, and 50 degrees is ultimately what the angle measures. Looking at B, it might be helpful here to kind of sketch in a 180 degree angle, just so I can see that for contrast, and then also a 90 degree angle, so I can see that also. And when I'm looking at this, I'm thinking this looks kind of close to halfway. So I remember that if I go by 45s, right, since half of 90 would be 45, I know that this would be maybe around 135 degrees. So maybe that's my estimate. So here's my protractor. And again, I'm going to kind of sketch that line down so you can see it better. And that goes right through 130 degrees. So again, that's a pretty reasonable estimate of 135. That's pretty close. If you're in the 120 to 140 maybe ballpark, that's pretty good. If you were more towards 110 or 160, right, then you might want to kind of revise how you're doing your estimates. Now looking at C, this angle here, again, it probably helps me to see a benchmark angle of 90 and 0. And in my mind, this maybe looks like a bit less than, say, halfway. I'm thinking maybe halfway is around here for 45. So maybe I'll call this around 25 degrees, for example, because maybe I think it looks a little bit bigger than half of 45. So then I'm going to check it out with my protractor, and I can see that this angle goes through 20 degrees. So again, an estimate of around 25, even 30, that's not a bad estimate. Even as low as 10, that's a decent estimate. But again, if you're estimating something like 60, right, that's pretty different. Looking next at D. So D has a big outside angle here, and it's a little tricky to measure that in some ways with a protractor. So what I'm going to think about is estimating this inside angle so that I can then figure out what the outside angle is. And so I'm looking at this and I'm thinking, okay, well, normally I would say, I'm going to go clockwise this time. I'm going to say this is 0, this is 90, and this right here would be 180. Again, notice that's going clockwise instead of counterclockwise like we've done sometimes. Both ways are technically correct. And so I'm looking at that and I'm thinking, maybe in my mind this looks like, maybe like going by 30. So maybe this looks like 120, 150. So in my mind, maybe this is around 150 degrees. And so the reason why I'm going to think about that is I can take 360 and subtract 150 so that I can actually find this angle over here. And so if that's my estimate, I'm going to get 210 degrees as my estimate up here. So to check now with the protractor, again, you're going to see my protractor is going to help me like kind of line up here and see that other smaller angle, but be aware I'm actually looking for this bigger angle here. When I look at it on my protractor, I see that it goes through 150 degrees, which actually matched with exactly what I predicted. And right, that means that this outside angle here, again, this big angle here, is 210 degrees. And finally, E. So looking at this, E is a pretty big angle. I can see if I sketched in approximately a straight angle of 180 degrees, I can see it's getting pretty close to that. Again, I might draw on some other benchmarks like 90, 0, but as I'm looking at this, maybe I would go by 30s, for example. So that's approximately 30s. So 120, 150. I mean, this is an interesting one because it seems like it's kind of halfway between 150 and 180 based on what I have. So maybe I'll guess that it's around 175, or sorry, 165, right? That would be about halfway between. So I'm going to make a guess. And now I'm going to look at it with my protractor. And I can see actually here that it is 170 degrees. That's how it lines up with my protractor. So ultimately, you want to have 170 degrees as your final measure. In problem 32, you're going to be drawing an angle for each of these. And so again, you want to be able to make these quite accurately, and it's a little tricky for me to do that with the tools that I have here, but you again want to be thinking about, for example, being able to construct a 45-degree angle, right? That's half of a 90-degree angle. So make sure that we're seeing an angle for 45 degrees. It's also even helpful if you label the measure of the angle. B should be an angle of 25 degrees. So right, if you were thinking about going, say, in thirds here, because again, I'm kind of sketching, but you should be drawing, this would be 0, 30, so 25 should be a bit lower. So I'm going to sketch it about here. So again, this should be a pretty small angle. And you want to check that with your protractor to make sure what you have is accurate. For C, 180 degrees, we're looking for a nice straight line here. And again, you can show, they mentioned include an arc indicating the turn. So you might show that there's a counterclockwise rotation. I can actually show that in my earlier ones as well. But this is 180 degrees. And finally for D, for 200 degrees. So you might think about here with this particular angle, often I would think about a straight angle here. And I might think about how this would be 90, this would be 270, right? So 0, 90, 180, 270. If I'm drawing a 200 degree angle, I might think about how if I went by 30s here, this would be 210 and 240. So I'm going to estimate that 200 is around here. Again, you're going to want to measure more precisely with your tools. So that would mean my 200 degree angle looks a bit like this. I'm going to go ahead and erase my other little benchmarks so it's a little bit more clear. And I'm going to draw my arrow showing the rotation. So this is my 200 degree angle approximately. But again, please make sure that with your tools that you're drawing really precise angles because we've been practicing how to do that in class. So today in class we talked about drawing specific triangles. And so you have some of these here as well to draw. And these are kind of challenging. So I encourage you to think about what we talked about in class. We talked about, for example, starting with the angle. And so in this case, I have a 75 degree angle. Again, my drawings here are not going to be quite as precise as yours, but again, we can try to make them approximate. So for angle BAC is 75 degrees. So I'm going to sketch a right angle here. And I know, for example, if I went by 30s, right, this would be 0, 30, 60, 90. So I'm going to say 75 is going to be, say, around here. Again, I know this isn't perfect. Yours was going to be a much better drawing than mine. I'm going to go ahead and erase my other lines here so I can pay attention to what I have a little bit better. And so, right, this is going to be my 75 degree angle. Now then in class we talked about you should label A, B, and C, or whatever your vertex kind of points are, whatever information they've given you about how the triangle is labeled. So in this case, they're telling me angle BAC is 75. And where I really have to pay attention is that middle letter goes with the vertex of the angle. So again, when I set this up, I'm going to go something like B, A, C. A has to be here. This vertex has to be here with the 75 degrees because again, that's how I know I put the right angle in the right spot. It's also okay if you switched these and you did C on top right here and B on bottom. That's okay too. But then when you adjust the sides, make sure that you are putting your sides at the right lengths. So that's the next step, dealing with the side lengths. So side AB needs to be 2 inches. And so I know, again, you'll kind of have to humor me here that this is 2 inches. And then side AC is going to be 1 inch. So I'm going to make that about half of what I have here and erase the rest of what I've got here. So this is about 1 inch. And then I'm going to go ahead and connect these here, right? And again, I can move C over further so it doesn't look like it's off by itself. But this is triangle ABC. It has a side length of 2 inches between A and B, a side length of 1 inch between A and C, and a 75 degree angle for BAC. So again, check your drawing and make sure that you have all of those components, right? 1, 2, 3 in your final drawing. And then for 35, we've got another triangle here, this time with 2 angles. And so again, we talked a little bit today, 2 angles. This particular triangle could look a lot of different ways, right? It doesn't give you any information about the sides. But when it comes to 2 75 degree angles, whatever you picked as maybe a side length, when you set this up, you're going to have 2 pretty big angles. And I know this is not my, again, most precise drawing, but you're going to have one that's 75 degrees and another that's 75 degrees. And you might notice that you might end up making a triangle with, for example, 2 kind of equal sides. You might remember this is an isosceles triangle. But again, when you set this triangle up, make sure that there are 2 75 degree angles. And again, you're going to say BAC is 75, so BAC. And then they also said ACB, right? So ACB is also 75. And you're going to learn tomorrow, or actually on Friday, more about how to find this other angle here in the triangle. You're going to learn about the sum of interior angles in a triangle. So that's what's coming here in a little bit.